Hello everybody, I am Mehmet Fatih Gürüş. In this video, I will be presenting our project, which is named as Adaptive Frequency Shift Gain Noise Cancellation System. I worked on this project with Elif Nur Bayser. Let's start with problem definition and motivation. In industrial setting, FSK communication system face severe interference from structured noise like drilling machines. And this narrowband noise can be mistaken for valid data, causing high bit error rates and communication failures. And our objective in this project is creating an FSK-based communication system enhanced with adaptive noise cancellation, simulating realistic industrial noise and measure performance improvements through bit error rate and audio quality. We used FSK in this project for the reason it has constant envelope and support for non-coherent demodulation, and these features make it robust and energy efficient and ideal for noisy, power-constrained environments. And also, of course, in the digital signal processing part, we use adaptive noise cancellation for the reason adaptive noise cancellation dynamically adapts to remove structured noise like drill sounds by using a reference signal. It preserves the frequency shift keying signal while minimizing error rates, especially when combined with RLS adaptation. Let's continue with the MATLAB. And in the MATLAB part, in the beginning, we are just converting the audio file to the TX file. But before doing it, we are resampling the voice to 80,000 hertz. And after doing that, I just want to explain the analog to digital. In this part, we are just implementing analog to digital conversion on MATLAB for the reason we need to work with binary data. So, and also I want to explain the recursive least square as well. And in this part, we are getting the noisy speech from the log view, and we are implementing our RLS algorithm in here. And after that, as an extra, we are implementing Hempel filter to cancel the peak noises in the signal. And at the end of this process, we are getting the cleaned signal from MATLAB. Before explaining the LabVIEW part, I want to say a few things for your information. In this project, we are using USRP NI 2000 and 900. And also on the computer, we are using LabVIEW communication system design suite. So let's continue with our transmitter. This is the panel of our transmitter. As you see, we have some selection parts. We can select our noise types, and also we can select our shaping filter as well. And also we can arrange our parameters in here. So let's continue with the diagram of the transmitter. In the transmitter, we firstly, we are deleting the previous file if we have. And also we are creating our message waveform in here to visualize it on the panel. And here we are implementing Hamming code encoding. After Hamming code encoding, we are modulating our signal. And after that, we are just sending it through the channel. So let's continue with the receiver. In the receiver, as you see, this is the panel of receiver. We again have some parameters in here that we can change. And as you see, we have 5 graphs to visualize the outputs. So let's continue with the diagram. And as you see, we are starting with the demodulating of the FSK signal from the channel. And in here, after demodulating the signal, we are starting to implement Hamming code decoding parts. As you see, this one is the signal that we get from the demodulation of FSK signal, and this is the reference signal that we get from the analog to digital converter to recognize the to detect the errors. And after implementing the Hamming code implementation and hard and soft decision correction, we are converting the signal from binary to decimal, as you see. And after that, we are getting the error impacted signal and error corrected signal to visualize them. And also, as an extra, we are calculating the bandwidth efficiency in here, and also we are calculating the signal to noise ratio as well here. So after we get the error corrected signal, we need to cancel the noise, as you know, the drill noise. And we are using MATLAB to cancel this noise. And we are calling the MATLAB file in here. And after that, we are getting the clean signal created by MATLAB. And after doing all of this, we are just playing the sounds and visualizing the signals on the panel. So let's see how the system works. Let me run the TX. Probably you will be hearing all the output sounds on log view. Just focus on the sounds and see the difference. See and hear the difference.
Merhaba. 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 Merhaba.
So I hope you heard the output sounds. And let me explain the transmitter part firstly. And this is the noisy speech, as you see. And this is the binary form of it. And this is the power spectrum of the noisy speech. And in the RX part, this is the baseband output, as you see. And this is the error impacted signal, which is impacted by Gaussian noise. And after hard and soft decision, we are correcting the signal and we get this error corrected signal. And after that, we are using RLS algorithm to cancel the noise from the error corrected signal. And we get this one without Hempel filter. And with the Hempel filter, we are canceling the peak noises. And at the end of the process, we are getting this clean signal. Okay, and error rates and error bit error numbers, as you see in here, and we get almost 65% bandwidth efficiency in this project. So let me play the sounds again and listen to them more carefully.
Merhaba. 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 Merhaba.
Okay, as you heard, the first signal that you heard is just error impacted signal. And the second one was error corrected signal. The third one was RLS output without Hempel filter. Probably you heard some peak noise in this sound. And the last one was RLS output with Hempel filter. Okay, thank you for listening to my presentation, and I hope you get the idea, and I hope it will be helpful for you in the future and in your future works.